Hello students. Today in this video we are going to see the determination of molecular formula and we will see how to calculate the percent composition and empirical formula from the given data. Now before going into what actually empirical formula is and molecular formula means, let us check out the definitions for both of them. So students, empirical formula, I can say that it is the simplest ratio in which we express the atoms, while in actual formula we are using the actual number of atoms that are present in a molecule. So I can write the definition for empirical formula as it is the relative number of atoms in the simplest ratio that we call it as empirical formula. And what is molecular formula? Students, for this empirical formula, you can say that the simplest ratio of atoms of the constituent elements in a molecule is the empirical formula of that compound. Now let us see what is molecular formula. Molecular formula indicates the actual number of constituent atoms present in a molecule. Now, by calculating the molecular formula and the empirical formula, we calculate their corresponding masses and thus we have a formula that is molecular mass of any molecule is equal to empirical mass multiplied by R. Now what is this R? This R is a multiple integral. So we can say that molecular formula is a integral multiple of empirical formula. To understand this better, let us take one example. This formula you must know, students, because we will be solving problems based on this. Now, say for example, I say that I have a compound whose molecular mass is 26 gram. By doing the calculation, you know that there is a carbon and a hydrogen, means its empirical formula is C and H only. Now what you have to do is, first we will calculate its empirical mass. So what is its empirical mass, student? This will be 12 plus 1, that comes to 13 gram. But according to this molecular mass, it is 26 gram. You are getting the empirical mass as 13 gram. So what is the value of R here? Value of R is 2 because R is equal to here molecular mass upon empirical mass. That is what you have used the formula here, this formula. So according to this, it will be 26 divided by 13, you will get 2. Means if you want to calculate the molecular formula, you have to multiply the empirical formula by 2. So what is the formula or the molecular formula is equal to CH whole multiplied by 2. So the formula is C2H2. So this is how you do the calculations. There are some proper ways to do the calculation to calculate the empirical and the molecular formulas. So let us go in detail and make some calculations based on this. Here are few problems what we'll be solving. Let us go through the first problem. A compound contains 4.07% of hydrogen, 24.27% of carbon and 71.65% of chlorine. Students, whenever you solve this type of problems, the possibility that oxygen is present in the particular formula is maximum, and therefore always take care that you will make a total of all the percent. If the percent comes out to 100, then you have to continue the calculation. But if the total is less than 100, then the total must be subtracted from 100 and the remaining composition is of oxygen that you have to mention, and you have to continue the calculation by taking into consideration the oxygen percent also. So this is the very important rule whenever you carry out any calculation for empirical and molecular formulas. So let us see this calculation now. As I said, the total should be 100, and therefore let us make a total and check whether the total is coming 100. So for that, let us continue now. If you see this, there are three elements which are considered here. So the first element is hydrogen. Second is carbon. Next is chlorine. So you have hydrogen, carbon, chlorine. Let us write all the percent which is given here. So I will write this. Hydrogen is 4.07. Carbon is 24.27. And this is 71.65. Students, if you make a total of all the three elements, this total comes out to be 99.99. So you can consider this because it is very much close to 100. You can neglect oxygen, but we will try to calculate oxygen also so that you will understand the proper way of doing the calculation. Now, as the total is below 100, therefore, total is below 100. Therefore, oxygen is present in the formula. Now, let us see what is that oxygen composition which is present. So, let us write the composition here, student. Composition, if I see, this will be 100 minus 99.99, and this will be 0.01% of oxygen. So, if you see this percent, this is negligible, and therefore we neglect it. If it is 1 or more than 1, then we would have continued this for the calculation. But you have to mention this, that the oxygen is this percent is very less, and so we neglect it. So let us continue the calculation by taking into consideration the three elements. Now here we have converted the percent in grams now. So this is, I got 4.07, 24.27 and 71.65 gram of the constituent elements. Now students, the next step is you have to calculate the number of moles of each constituent element. So what you have to do while calculating the number of moles, you have to divide the given mass by their masses which are given. So if you see the question, they have given the atomic masses, and you have to use the exact value of mass what they have given in the data. So let us calculate the number of moles. Here for hydrogen, it will be 4.07 divided by how much they have given for hydrogen is 1.008. For carbon, I will take this number, that is 24.27 divided by mass of carbon. So I can take it as 12. For chlorine, it is 71.65 divided by this what they have given. Students, you have to round off this number for the calculation. Now I can go only for 4 digits because we'll be using log calculations, and therefore what I should do with this is less than 5, so I can neglect this. So I will take this 35.45. Let us go for log calculations now. Now log of, this will be log of 4.07 minus log of 1.008. For my convenience, I am removing, you can remove the decimals from here. So I can remove two places decimal to this side. Same I have to do here. So I am removing in this way. I got 407 upon 100.8. Here no need to remove the decimal because it is comfortable calculations. So let us proceed for this. It will be log of 407 minus log of 100.8. So it will be 2.6096 minus log of this will be 2.0033. If you subtract, this will come to 0.6063 and antilog for this comes out to be 4.039. So the number of moles for hydrogen, what I got is 4.039. Similarly, let us go for this. So this is what I calculated is for hydrogen. Let us go for carbon now. Carbon, it will be log of 24.27 minus log of 12. So it will be, this log is 3850 and this log is 0792. If you see the difference here, this will come to 3058 and antilog is 2.022. Let us move on to chlorine now. So chlorine will be log of 71.65 minus log of 35.45. This will be 1 point, how much will be this, student? It will be 8552 and this is 5496. Now when I subtract this, this will come to 0.3056 and antilog for this will be 2.021. So I got the number of moles. This is for hydrogen. This is for the second element, that is carbon, number of moles. And chlorine I got 2.021. Now next step is you have to find the lowest or the minimum number of mole what you have calculated and divide or use that for dividing all the moles. So how I will move on to the next calculation, student? My first step was I have converted the percent into its corresponding masses and now I have to convert this to number of moles that I did here. Now the next is I have to divide the moles value obtained by the simplest value among them. So what will be the next is I'm trying to calculate the ratio. So this will be 4.039 divided by, if I see the value, this is the lowest one. So it will be 2.021. This will be 2.022 divided by 2.021 and 2.021 divided by 2.021. If you see this, they are very close. So this will be 1:1. Let us go for this calculation now by using log. Because if you see this, you can simply sort out this. This will come to 2. But let us try this by using log. It will be a practice also. So here, log of 4.039. This will be 0.6063 minus 0.3056. Difference will come to 0.3007 and antilog will come to 1.999, which is nearly equal to 2. So what is the ratio now, students? The ratio will be hydrogen is to carbon is to chlorine is 2:1:1. So what will be the empirical formula here? So let us see that. So students, the empirical formula will be H2. You have to write the coefficients in this way. C1, we don't write 1, so it will be Cl. So it is H2CCl or it will be CH2Cl. So this is the empirical formula of the data which is given in the problem. So based on this, can I calculate its empirical mass? empirical mass is equal to, you have to make a total of the masses here. So this will be 12 plus 2 plus 35.5, or what is given is 45. You have to use the same value. So this will come to 49.45. This is what we got. Now if you check out the question, they have given the molecular mass here and the molar mass is 98.96. This is given. So I have empirical mass here. So molecular mass which is given is 49.45. So what I can get, student? I can get now the integral multiple value. So what will be that? So that R, because you know that molecular mass is equal to empirical mass into R. So what is R is equal to? Will be 90, sorry, what is the molar mass given, student? It is 98.96. So R is 98.96 divided by 49.45. So what will be this? Log of this minus log of this. So let us go by log only. 1.9955 is the log for this. And log of 49.45 is 1.6941. Difference comes out to be 0.3014 and this comes out to be nearly 2. Means what, student? R is equal to 2. Now when R is equal to 2, your empirical formula is what, student? Your empirical formula is H2Cl. So molecular formula is equal to empirical formula into 2. So your answer is C2H4Cl2. So this is the formula or the molecular formula for the given question. So structure might be something like this, what we have. So it will be in this way, Cl, Cl, H, H, H and H. So this is how you go for the calculation. Let us try one more problem and now we will do that according to the step. Now you will understand that better because we will be following the steps what we have used here. So let us start for the next problem. The next problem what is given here is a compound with molar mass 159 was found to contain 39.62% copper. So the first element here is copper and the second element here is sulfur. So let us start for the problem. You can solve this simultaneously, students. It will be a practice for you. So if I see the problem, there are only two elements which are given and they are copper and sulfur. So let us write down copper and sulfur. What is the percent what they have given? Copper is 39.62. So let us write 39.62% and this is 20.13%. Let us make a total. So the total of copper plus sulfur, this will come to, that is 39.62 plus 20.13. So this comes out to 59.75. So you have to make one statement as this total is less than 100. Therefore, the third element is present and that is oxygen. So therefore, oxygen will be how much? 100 minus 59.75. And if you calculate this, this will come to 40.25. And this is a big digit, big value. So you cannot neglect this. And therefore, let us make a chart now. The copper you have is 39.62%. Next you have sulfur which is 20.13% and now you have oxygen also which is 40.25%. So this is what you have to use now for the calculation. So you have written this. Now let us come to the second step that you have to calculate the number of moles. So number of moles will be 39.62 divided by its mass which is given in the question, that is 63. Same you have to do here, 20.13 divided by How much is given? Same value you have to take, 40.25 divided by 16. Let us go by log calculation now. It will be log of 39.62 minus log of 63. So this will be 1.5979 minus 1.7993. Difference comes out to bar 1.7986 and anti-log comes out to 0.6290. Let us go for this. Log of 20.13 minus log of 32. So this will be 1.3038 and 1.5051. Subtract this. This will be bar 1.7987 and anti-log will come to 0.6291. You can go for this. Log of 40.25 minus log of 16. So this comes out to 1.6047 minus 1.2041. So the difference comes out to 4006 and anti-log will come to 2.516. So students, we have calculated the number of moles. That is our second calculation we have finished. Now what is the third calculation? You have to select the lowest value and that you have to use to divide rest of all the values. So let us go for this. If you check out, the lowest value is this. So the third calculation is 0.6290 divided by 0.6290. 0.6291 divided by 0.6290 and 2.516 divided by 0.6290. Now this is very close. You can go for log or it will be nearly 1. So I'm not doing the calculation here. So what you will get is the simplest ratio. Now what will be the ratio here is 1 is to 1 is 2. To do this, I need to go by log here. So it will be log of 2.516 minus log of 0.6290. So how you will go for the calculation? So it will be, let us see the calculation here. So the log for this will be 0.4007 minus bar 1.7987. Subtract the 2, you will get 0.6020 and anti-log comes out to 3.999, which is nearly equal to 4. So this value comes here as 4. So what is the formula now, student? Based on this, now I can give the empirical formula. So empirical formula is equal to, the first element is copper. So I will write copper. It is 1. We usually avoid writing 1. So I will simply put it as Cu. Next element is sulfur. This is also 1. So I will write it as S. Next is oxygen and which is 4. So I will write this as O4. So this is, that is CuSO4. Now based on this, let us go for its empirical mass. Empirical mass is equal to, whatever the masses they are given in the problem, you have to use the same. Here they have given 63 for copper, 32 for sulfur and 16 for oxygen. I'll be using the same values here. So this will be 63 plus 32 plus 16 into 4. If you do the calculation, you will get 159 gram. This is empirical mass. Now in the problem they have given the molar mass and that is 59. So when the molar mass which is given in the problem is also 159. So what will be the value of R, student? R is equal to 1. So what is the molecular formula? Molecular formula is equal to CuSO4 into 1. Means its molecular and empirical formula is same. So your answer here is CuSO4. Students, when the R value is 1, then the empirical and the molecular formula will be same. I hope you like this video. So please Like the video and share it with your friends, and don't forget to subscribe my channel. Thank you, students.